Hello, my name is Andrew Elizalde, and this is just a first run at a video. Welcome to my man cave, also known as the new recording studio for classicalcaveman.com. I'm going to be working on learning how to edit some videos and hopefully post stuff that's going to be valuable to classical Christian schools and also particularly math teachers. So just to get some footage that I can work with, I'm going to go ahead and start with an explanation of how to complete the square for a very simple quadratic equation. We'll just do a simple one and I can save explanations for harder ones later. So here we go. All right, let's take this quadratic formula. It might look or quadratic equation. It might look factorable. We can try to factor it as a way of solving it, but it's not really going to factor. So x plus 3 aren't going to work because we need that -9 at the end. So I'm going to add a 9 to both sides just so I can focus on the x squared plus 6x. And now what I want to do is create a visual for x squared plus 6x so we can actually talk about the process of completing the square. So for x squared plus 6x, I'm going to represent x squared with a square. The sides of the square are of length x, that makes the actual area of the square x squared. And a rectangle. One side of this rectangle is already x, so the top side is going to be 6. And the area of the rectangle is 6x. So this area represents x squared plus 6x, but clearly this area is not in the shape of a square. We want to get this to be in the shape of a square. So to do that, we're going to do something clever. We're going to take the rectangle and split it in half. So if I split this rectangle in half, what I'm left with is an x squared and a 3x. And I just can't remove the other 3x. What I'm going to do is I'm actually going to take it and slide it over down under here. So I still have the same x squared and 6x. The 6x is just split up into two parts. And what you're going to notice is I have the beginnings of a square. On one side I have a length of x and 3, and the other side a length of x and 3. Hold on, I'm recording this. So if I look down this side, the sum of these two lengths is x plus 3, and the sum of these two lengths is x plus 3. And so these two sides are exactly the same length, which means we're about to form a square. All we need is a little bit more to complete it. And so I can look to see how much more is required to complete that. If I look over here, I have a dimension of 3, and if I look up here, I have a dimension of 3. That must mean that if I add 9, I can complete the square. So now I can add 9 to both sides of this equation, and I get 18 equals x squared plus 6x plus 9. Now the right-hand side is a perfect square trinomial. X squared plus 6x plus 9, the area of this square right here, can be represented as the product x plus 3 times x plus 3. Now that I have a term squared, I can get rid of the square by taking the square root of both sides, not forgetting the plus or minus. I'm going to add a -3 to both sides. And then simplify the radical expression. And now I have the solution to the quadratic -3 plus or minus 3 root 2. And that's the process of completing the square in order to solve a quadratic. Of course, this gets more complicated when the coefficient on x is odd, or if there's a coefficient on x squared other than 1. And I'll be explaining that in later videos. But for now, let's let this just be some footage that I can edit and begin to figure out how am I going to make videos and how am I going to get them out there for you guys to use at your schools.